guys, welcome back to the shop. Frank here, working on the Cub Cadet mini bulldozer build. I've taken the tension wheels off. I'm going to weld up these small spacers to the plates. This will provide some more bearing surface, even though these shafts will rotate in these bearings supported on these arms. I want more than just the 1/4 inch plate, hole through the 1/4 inch plate to be the bearing surface for that. So I'm going to put some small welds on those to hold those rings or spacers in place on the wheel. And then I just finished cutting out 3 new track pads, and actually had a mistake here, but cut out 3 new track pads. I'm still learning how to use this plasma cutter. One of my programs, instead of 40 inches per minute, I somehow typed in 401 inches per minute, and of course it just blasted through it. It didn't cut through the steel, it just etched it. So I had to go back in and redo that. But common mistake, I guess. Typo. Alright, so I've got 3 track pads that are slightly smaller in width. They're 4.8 inches. So I think they'll give more space between the pads. And then I've got some 1/2 inch steel bar, flat bar, 1/2 by 4. And I'm going to cut a length of this out and then set it on the plasma table and cut the spacers, which will space the actual chain off of the track pad itself. And I think we'll mock that up. All right, so let me get these 2 wheels welded up and then move them off the bench and work on the tracks. Certainly when you weld that, it tends to pull the ring away from the, but it's still, want to make sure the shaft fits properly. Okay, so that's all I need was a small weld to hold the ring in place. All right, so this is the plate which will go between these two support arms. I need to grind these tabs down a little bit so they fit in these slots more easily. I don't know if this is worth the effort, but I'm going to give it a shot. I'm trying to save this vanity plate. This is the idler looking plate that goes over the sprocket to make the sprocket look like the idler wheel for the track. And you can see the plasma cutter did not complete this hole. The issue with that situation is that the plasma cutter hardens the metal around the hole, so it makes it difficult to drill it out or mill it out, for example. I probably have an 1.25 inch, these holes are 1.25 inch end mill, but it would just ruin the end mill, high-speed steel end mill. I don't have a carbide end mill that size. I have that will do a center cut. It will cut around the edges. You can move it sideways, but which is what my plan is now. So my plan is to drill out as close to the hole, at the edge of this hole, as I can with this drill bit, which is inexpensive to replace if it gets ruined. I'll drill close to that, and then I'll come back with a 1.25 inch carbide indexable end mill and clean up the circumference of the circle. Well, there it just toasted the end of that drill. It went fine through the first hole, but it hit a hard spot and messed up that drill. All right, let me get a different drill. I'm going to use some inexpensive drill bits, odd sizes, so we'll see how this goes. Kind of sacrificing a couple drill bits. I mean, I could cut another plate out on the plasma table, but well, as you can see, that didn't actually drill through, but it did push the plug out. All right. Let me swap out the drill chuck for the end mill. So it looks like it cleaned up that hole pretty well. So I think that's going to be fine. That worked out okay. That carbide end mill only cuts around the edges. It doesn't cut in the center. So that's why I had to drill out the plug first. Okay, so I think that saved this disc, which, you know, given the cost of 1/4 inch steel plate I think it's $500 a 4x8 sheet. So half a sheet, so that's 32 square feet. You know, it's like $15 a square foot. So this being, you know, this probably takes up a couple square feet in terms of usage. Big circles waste a lot of material on the chart, so it's probably, you know, $30 worth of steel that I managed to rescue here. Okay, well, I'll take this off. I'm waiting for the machine shop to press the longer studs into my new my wheel spacers that'll be used to mount these plates on the sprockets, but once I get those back, we'll put those on. And I'm still waiting for the bogie wheels as well, so I can finish assembling the other 5 bogie carriers. I did cut out the pieces of angle iron, 10 pieces of angle iron that I'll need to go on top of the bogie carriers, and that's these angle iron here. So, all right, so that's one of the bogie carriers. We got to make 5 more of those. All right, we'll come back. All right, these are the vanity plates. Call them that. They're the covers for the sprockets. Just need to get this whole area smooth because it's going to go against a wheel spacer, so it needs to be smooth and flush. Looks like there's one hole which is undersized here. This is going to be a problem. All right, even with these longer studs, it's not long. They're not long enough for me to get the lug nuts because there's almost a ½ inch of space here. It only leaves a couple threads, so I have to drill these out. It's not a strength issue because all it's going to do is hold on this plate, which won't go on because these are in the way. All right, I need to get a counter bore to also touch up each of these. All right, so this is the spacer with the longer studs. All right, so that makes the sprocket wheel look the same as the idler wheel. And as you can see, there's plenty of space for the track to go around it there. In order to put the vanity plate on here, I need to take these C-clamps off, and I'm not ready to do that. I'm still working on the position here of the idler, of the tensioner pulley, tensioner wheel. So I think I'm just going to leave that the way it is, and we'll come back later and put the plate on. Hey guys, back in the shop this morning. I thought I would turn my attention to the dash. I was getting ready to put the dash, go ahead and mount the dash permanently, but I realized that I have some work I need to do to it. I need to take this bracket off, this arm. It has a rod which goes through the middle, and you take that out. I need to clean up the wiring harness. It's got some interlock connections on it that need to be bypassed because we're not going to use them. This is the cable which goes to the battery. This is the cable which goes to the starter. Of course, I've got choke and throttle cables, and of course I'm going to use them. There's another cable which goes to the starter generator that provides charging power back to the voltage regulator, and here's the cable that goes back to the voltage regulator, and probably the rear lights. Yeah, I'm going to guess this is probably front lights. So I'm going to go ahead and, this harness is actually in pretty good shape. It's not, the insulation is not bad shape. So I plan to use it as it is, with the exception of bypassing some of these interlock connections. So I'm going to do that here and take this off, and I'm going to take the decals off, clean it up. As far as the top surface here, some of this I'm going to keep. The choke and the throttle, charging meter, that's fine. I'd like to keep the international label. I think this is where the hydro control comes through, and of course this is where the steering wheel comes through, neither of which we need. So I would like to keep this as much as I can, but I don't need these, so I'm thinking a plate of some sort to cover this, and maybe we'll use another control. I'm not sure whether we'll put the what I'm going to do. I mean, I've got ideas for, you know, the dozer, including a, you know, a rear scar fire or ripper. I don't know that I have enough horsepower to actually really use one, but it would look cool. The possibility is a winch, and I could put that on either the front or the rear. Traditionally, I think the winches have been on the rear. You know, all those things are like future projects. I mean, my focus now is obviously to get a running frame, you know, that works. And then the second major thing would be the blade and the hydraulics associated with operating the blade. So I'm not real sure what I'm going to do with this dash at this point. My tendency right now is probably just to leave it as is for the time being, and when I do decide, then I can modify it. I don't want to, you know, there's some charm in keeping the Cub Cadet looking dash. If I have to modify it, you know, with putting alternate controls in these holes or something like that, that'd be fine. But there is some appeal to keeping the Cub Cadet look and feel, right? But given that, I still need to clean up the wiring harness. I don't need the PTO lever, and but I do need the choke and throttle cables. So I'm going to work on that stuff this morning. It's a cold and wet November. This is the Thanksgiving week actually right now. So it's cold and wet outside. I think so I can't, when it's raining outside, the dogs spend a lot of time in here. So I don't like, and when I'm welding or running the plasma table, they have to leave. So I don't like forcing them out when the weather's messy. Cold's no problem, but rain and actually they don't care about the rain that much, to be honest with you. But I feel bad forcing them out in bad weather. So I'm not going to run the plasma table today or do any welding, but I'm going to work on this. So I'm going to work on this dash. So I've hooked a positive lead of this jump pack to the battery cable, and the negative clamped it to the frame here. I want to check this solenoid to see if it's working. I don't have a ignition key here handy. I usually have a couple spare ignition keys in my stash, but I don't see one in there. I could go get one from one of the other tractors, but I can test just to make sure by jumpering. The ignition lead to the terminal here on the solenoid starter relay and actuate it, so I know that's working. That's the main thing that you want working, because that lets you start the tractor. And let's see, one of these, those go to the starter generator, they go to the charger. Okay. All right, so one of these goes to the coil. I'm going to say this one goes to the coil, and then this one goes to the starter generator. So I'll need to get the key switch to make sure I have power to the coil. But this came off of a running tractor, so I think it's fine. I'm going to go ahead and bypass this connector. Some people jump these, just plug a bent piece of wire between. This goes to the clutch or brake switch. When you press you have to press the brake switch down. This is a hydrostat, so it doesn't have a clutch, but you have to press the brake down to make up the contacts on a switch, which then closes the circuit here, shorts these two leads together, which lets you start the tractor. And the other switch is a PTO switch, which doesn't let you start the tractor unless the PTO is disengaged. And so there's another switch that one of these leads goes to, or these two leads go to. So we'll look at that and bypass that as well. All right, so we're going to bypass this lead. I mean, just as a, it's interesting on the Cub Cadets, and maybe this is the reason these tractors last so long. The wires are tinned, which is normally you see only on marine wiring. The tinned strands, that is, the individual strands of copper wire are coated with tin for corrosion resistance. So and it's just a little, I mean, that's an extra expense that International went to when they built these tractors to make sure they lasted a long time. It's you don't see tinned connectors on stuff very often, unless it's a boat. And even on some of the less expensive boat brands, they don't even use tinned wire, which is kind of a crime. And we're just bypassing this since we're not going to use that. I mean, I could also bypass it at the ignition switch, I guess would be another way of doing it, but this is easy. Okay, I went and got an ignition switch. These old Cub Cadets, there's really only two keys that fit all the tractors. This is the key for the wide frame, some of the later narrow frame, most of the later narrow frame, wide frame, and then there's a different key for the quiet lines and later. But anyway, so I went and stole that key off of another tractor, and it actuates the solenoid. Okay, let's see if we get 12 volts at the coil connection, which I believe is right here. So between here and negative, and yes, I have 12 volts showing on the meter. Okay, so we've got ignition got the relay for the starter, and we've got power to the coil. So those are the two key things we need to make sure we can start the tractor. I don't have to bypass these other connectors. All right. Let's look at taking this bracket and the actuator arm and rod out. Alright, so I was able to, once I got the roll pin out of here, went through like this, I was able to drive this rod out off of this connector. So we've got this off. And that's basically everything we need to take off of or modify on this right now. Alright, so choke cable works, throttle cable works. So I think the next thing to do is go ahead and remove the decals on both sides. That sometimes can be a little bit of a problem. I mean, they're so old. This is probably a mid-70s tractor, 72, 73, 74, something like that. So, I mean, it's close to 50 years old. This looks like an original. I believe this is original decal, or at least it's an older one. It's not a repop. Well, this is coming off easier than they usually come off, but I'll take that. All right, we'll sand the rest of that off. That one came off easily as well. See if I can get this little... And we can sand that off. I'll tell you what, I've got the heat gun out. Let's get the hood. This hood looks like it's been varnished. I mean, there's some kind of a clear coat on here. I don't know if you can see it on the camera between here and here. But it looks like the decal was unmolested. So let's see if we can get that off as easily as the one on the dash. If you have trouble getting these decals off with a heat gun, and I have to say, this is I'm going to say is working surprisingly well. Generally, it doesn't work this well. But this is the thing you want to try first. You can take it off with a paint remover wheel on a grinder. It doesn't look like it's going to come off very easily, so I'm going to go ahead and grind it off. I wasn't planning on taking that whole thing down to bare metal. I mean, I didn't do the whole hood, but there was a lot more rust underneath the paint than I was expecting. And, you know, there's some bad areas. So this hood definitely has been, at some point, was repainted and had new decals put on it. I'm going to guess now. Being as it's 50 years old, it's not surprising. So I got most of the paint off, and with the rust restorer, that I use, I don't need to get all the rust off. And I'm not going for a showroom, you know, a show finish on this tractor. So I'm going to go ahead and wipe this down with some acetone and hit it with a coat of primer. And we'll come back and decide when to paint it. I think I have the white paint to do it now. Not anxious to do final paint job on really anything on the tractor until, you know, it's nearly complete. But I think the hood and the dash, don't have a whole lot of extra work to do on those, so I might go ahead and paint those. And I have to order a set of decals. I'll have to do that. Okay, well, let me get the acetone. We'll wipe this down and put a coat of paint on it. Alright, so that's all the dash really needs is clean it off, get the decal residue off of it. And the top half of it's fiberglass. I don't think I'm going to do anything with it, but I will hit the sides of it with some primer. In order to paint the fiberglass section, I need to mask off the dash graphics. I'll do that later. Alright, let me just hit this stuff with a quick coat of the Rust-Oleum Rust Reformer primer. Alright, got a coat of primer on those parts, keep the rust under control. I've got my HEPA filtration system running up here, but it's not a hydrocarbon filter, so I need to get out of the shop here for an hour or so to let the fumes die down. Alright guys, that's all the time we have for this week. I was hoping to get the bogie wheels, but it's been over a week since I ordered them, and I've got to wrap this episode up. As you can see, we've got the tensioner wheel. It's not in its final position, but at least it's temporarily mounted there. Got the vanity. Let's get over here and look at the vanity cover on this sprocket, so the sprocket will look like the idler wheel. I've got the other tensioner wheel over here, and once the rest of the bogie wheels come, I can finish assembling the other bogie carriers, and we can put the chain on it and cut it to length, work on the final position of the tensioner and mount that. And then the track frame's coming off, so I can finish welding up the laterals, drill any holes I need for the bogies, and then work on getting that back together. If there are additional delays on getting the bogies, then I'll just shift my focus to the hood and grill and dash and get that assembled, and maybe even, one of the things I do need to do is get the engine hooked up. Needs electrical hookup, and for the starter, for the ignition, and it needs a carb, air filter, that sort of thing, muffler, those parts put on it. So those are additional things we need to do to get it running. I feel like I'm closing in on the getting to a running machine. I do need to work on the tracks themselves. Once we get the chain, the exact length of the chain determined, then I can shift my focus to building the track pads and creating the track itself. But that'll come after the rest of those items are taken care of. So, all right, thanks for watching. Appreciate a thumbs up, and subscribe if you haven't already subscribed so you don't miss upcoming episodes. See you guys next time.